we get down to business, a couple of logistical points. This webinar is being recorded, and the reason we do that is because we make the webinar available on our events and webinar webpage, so that if you enjoyed the webinar, you can feel free to pass on the link to other colleagues that you think might be interested. Or if you were particularly interested in something, you can log on and do a repeat performance for yourself if you'd like to. Being recorded, and because we have had some background noise in the past that's interfered with the recording, we're going to actually try something a little bit different this time. Evidently, the software that we have for the webinar allows me to mute everyone else's phones. So we're going to try that out this time. What's going to happen then is if you'd like to ask a question, of course, what you're going to have to do in order to ask a question is you're going to have to unmute your phone by pressing *6. So I'll let you know the point that I'm going to mute the phones, I'm going to ask you to hold your questions until the question and answer session. We have 30 minutes. The webinar is an hour and a half long, and the last 30 minutes from 4 to 4:30 is meant to be for questions and answers. The way that you let me know if you have a question is in the lower right-hand corner of your screen, you should have a little button that has a little hand on it. If you press that little button, and feel free to go ahead and try it now. There, Nick, I see your hand. Paul, I see your hand. Michael, hand, yeah. And then if you wanted it to disappear, you just press it a second time. Dill, I see your hand. That lets me know that you have a question, and because we're going to have so many people on the phone today, obviously when the question and answer session opens up, if we have 30 or 40 people all talking at the same time, it doesn't work that well. So if you do have a question, raise your hand, and I'll try to kind of take the questions. I'll try to keep them in order, and that's how we'll try to proceed. And I'll give you another reminder when we start the Q&A sessions about how to unmute your phone. Once I do mute everybody's phones, if you're having a problem and you try to talk and I'm not answering, if you can't figure out how to unmute your phone, for this webinar I am keeping the chat function active. So if you look towards the lower right-hand corner, you'll see a little box that says chat, and you'll see all the way down at the bottom, underneath where it says send to all participants, you'll see a little box. Mine says select a participant in the end menu first. So you have to click in there, and then you have to type in what you want, select under send to all participants, and hit send. See there, I just did it. That's how it works with test email. So if you have problems and nobody can hear you, it's probably because something has gone wrong with the mute function. Just feel free to use the chat. I'm going to, now I'm going to try muting everybody's phones.
Who has muted your line?
Okay, I'm assuming that everybody can hear me. Continuing here with the webinar. I'd like to introduce our speakers for today. Speakers are, after me, Cliff Timko is going to be giving an overview of leak prevention and repairs. Then we're going to William Gallahan from Giant Eagle. He's going to give an overview of refrigerant management at Giant Eagle. And then he's going to hand over to John Perry from Farm Fresh, who's going to do an overview of hydrogen leak testing at Farm Fresh. And then, as I said, we'll open up for the question and answer period. So right now, I'm actually going to just hand over to Cliff, and we're going to get started on Cliff's presentation. So Cliff, ahead. It should be...
Keeley. Can you hear me?
Yes.
Okay, great. Good afternoon, everyone. What I'll be talking to about today is the green chill leak reduction that we're putting together to help reduce refrigerant loss in supermarkets and to try to reduce and prevent leaks and repair them on a rapid basis. It's a guide that's going to be coming out shortly. It's not a cookie solution for any of the stores. We're going to cover everything on a broad basis. Supermarket refrigerant leaks in a typical store now average 20 to 25%. Green members have been able to reduce that leak rate in half down to about 12.5%, and individual partners have been able to reduce it even further down to under 8%. And partners have advanced refrigeration systems with best practices been able to achieve rates on individual stores of 0 to 5%, which is remarkable. The 8 categories that we picked that contribute to refrigerant leaks in supermarkets. Compressed racks are number 1 in most supermarkets, and these racks are generally purchased prefabricated from a major supermarket refrigeration manufacturer, and they have manifolds, receivers, valves, oil system, and controls factory installed to reduce field labor and possible hope that it will also improve the installation quality. Leaks occur on the racks. A number of components and fittings located on a common frame within a confined space and subjected to the constant vibration from the compressors. Number 2 item is usually display cases, and that's because of the high number of cases in a store, with kind of 100 or more cases not being unusual. And the number of leak points on each case with the evaporators, expansion valves, and other components all squeezed together in a tightly confined space in the bottom of the case under pounds of refrigerated product. Number 3 is the remote condensers, and they're located outside, usually on the roof, which may not be easily accessible, and where refrigerant leak monitoring sensors aren't effective. So any leak that occurs on a remote condenser could go undetected for a significant time and could create a significant leak. Remaining 5 categories usually account for less than 30% of the total refrigerant loss in a supermarket. While evaporators are installed in rooms, and any leak that's created is quickly picked up by a leak monitor or during a PM leak check, so they're usually not a major problem. Installed piping is a surprise. With 1,000 feet of piping in the average store and hundreds of feet of brazed, or hundreds of connections installed, in the store in various locations where they're not easily picked up by leak detectors, the amount of loss that's attributed to field piping is usually fairly low, and of course varies widely from store depending on the quality of the installation. Units in most new stores are only used on an infrequent basis and represent a small portion of the total refrigeration system. and they're primarily used today to add capacity if you're putting a lineup or two in for small remodels. Top AC units hold a relatively small refrigerant charge. Those are the ones that are used probably by most companies today. Compared to a rack system, that's a relatively insignificant charge. They're all factory assembled, and the leak potential on those are relatively low. Wood headers have suction and liquid manifolds and valves normally installed on a rack or installed on these remote headers located somewhere between the compressor and sales area. It can help shorten the piping runs. And from a loss standpoint, the advantages are that they're not subjected to the vibration from the compressors. There's also overall less field piping. So the disadvantage is that a lot of times they're located in remote locations and may have fewer leak checks. Here are causes of leaks. Leaks occur in brazed joints from improper brazing techniques. This is due to improper cleaning of the joint prior to brazing, using the wrong brazing alloy, not heating the joint uniformly, or the proper temperature before filling it with brazing alloy. Leaks occur also on threaded and flared fittings when they're not tightened sufficiently, and of course they're also subject to vibration, loosening vibration. In the other extreme, they also could crack as a result of being over-tightened. Leaks occur on valves due to missing on valve stems and caps on Schrader cores. Should have the cap in place, and a lot of times the caps have included in there an O-ring or a seal that need to be in place as well in order to keep that valve stem from leaking. Picture shows a couple of Schrader valves there without any caps. It's very common in a lot of stores, especially older stores, over a period of time. Seals exposed to HCFC refrigerants swell at a different rate than seals exposed to HFC refrigerants, and if your system is being retrofitted from an HCFC to an HFC, the gaskets or seals in the system may need to be replaced. Most vibration in refrigerant systems occur on or near the compressor rack due to discharge line gas pulsations, and vibration will also create added stress to any joints or fittings, which eventually lead to failure. Severe discharge vibrations can cause clamps to break, as you can see here in the photo, which can lead to broken lines and fittings. Refrigerant lines change dimension due to temperature and results in expansion and contraction of the tubing. A degree increase in temperature will expand a 100-foot copper line by over an inch. And the temperature change is common in hot gas defrostation lines. The line is prevented from freely expanding by being blocked by a support or a wall. Thermal stresses on the pipe can cause severe bending of the tubing or breaks in the fittings at the port joints. And a well-engineered system should have expansion loops designed into the system to absorb these thermal stresses. Evaporator coils in contact with food acids, such as in deli cases where it could come in contact with vinegar, could corrode that coil over time and develop pinhole leaks, as you can see in that bottom photo of a deli case coil. And there are coatings available, case manufacturer or coil manufacturers, to help prevent this corrosion. And corrosion leaks also occur on compressor rack components, as you could see on the rack on the previous slide. Without proper maintenance, steel components on a rack, suction filter shells, suction valves, even receivers mounted below a suction manifold can quickly deteriorate due to this corrosion, and if treated, could lead to refrigerant leaks. Copper tubing in direct contact with other tubing or harder steel supports or concrete can rub through the tubing walls and create leaks. And improperly spaced supports could cause copper tubing to sag between supports or 90-degree turns, creating unwanted stress, and this stress can lead to broken lines or fittings and leaks. Supermarket personnel are faced today with the primary job of running a store and satisfying the needs of their customers. And although most companies agree with the need to minimize leaks, it's not a top priority, and most lower-level associates don't appreciate its importance. To emphasize significance and consequences of refrigerant leaks, all companies should establish a corporate-wide no-tolerance leak policy. This policy can greatly influence the attitude of store managers and technicians towards system maintenance and leak repairs. Without attitude, leak checks and tests may get overlooked and result in unnecessary and preventable leaks. While management may support a no-tolerance policy for refrigerant leaks, it's important that senior managers openly acknowledge and encourage the policy so the message is reinforced throughout the company. Saying if it's not important to my manager, it's not important to me. And to help senior management get on board, they have to be made aware of the potential savings of both refrigerant and service costs. In supermarkets today, the refrigerant is typically between $6 and $10 per pound for the cost of refrigerant, and that doesn't include the contractor markup and labor costs that add even to the cost of the refrigerant. So unusual for a store to have an annual refrigerant replacement cost of $10,000 a year. And leaks are not only harmful for the environment, they're also bad for the company's bottom line. The company has decided to make leak prevention a priority. The next step is to place a refrigerant system in your stores and in your company. Leaking is an essential component to the refrigerant management system and to a program that you would have. Tracking systems enable companies to easily quantify leaks, isolate leak sources, and manage refrigerant leaks across multiple stores and systems. Refrigerant tracking also allows companies to benchmark their data against industry trends, set and meet reduction goals. And track systems enable companies to hold individual stores accountable for their leaks and makes it possible to reward store employees, service technicians, or contractors for good practices. While tracking systems can be useful, software-based systems are more efficient and proactive in tracking refrigerant leaks. Some programs are currently available that can track inventories, serving dates, quantities, refrigerant types, system capacities, leak frequencies, and component failures. Software should be accessible by the service technician at store level, and each technician should be trained to input the information for every leak event, repair, refrigerant addition, or verification of the system. And should include the refrigeration system ID, the leak location, the type of failure, and the quantity and type of refrigerant added. Software should also automatically perform the EPA-required leak rate calculation, and the person should be able to be automatically notify a company manager or dispatcher that the system has excessive leak rates. A large leak occurred, or if there's a need for to schedule a verification check. Refrigeration systems make it difficult for technicians to spot leaks, and equipment can give technicians the impression that a store is not concerned with the maintenance of equipment. Motivating service technicians is the key to the success of a leak reduction program. You instill a sense of pride in your technicians. Refrigeration racks as well as the entire mechanical room, should be maintained to as clean a level as possible. Compressor racks and their components should be free of oil and dirt. Corrosion on steel components should be removed, and the components painted with a rust-inhibiting paint to prevent further corrosion. The room should not be permitted to be used as storage areas by store personnel. Besides the obvious safety concerns, the clutter reduces the technician's productivity, adds to his frustration, and increases maintenance costs. As a result, equipment in mechanical rooms should be cleaned on an annual basis. Oils and other substantial messes should also be cleaned up as they occur. Refrigerant leak monitoring and alarm systems allow us to respond to major leaks that could develop between regular leak inspections. Leak detection systems could be direct or indirect. Direct leak detection system measures the refrigerant leaking an air sample near a refrigeration system or one of its components. An indirect system would measure changes in receiver refrigerant levels or the weight, condenser receiver assembly, or a system temperature increase. Often the first notification of a refrigerant leak in a store is a base temperature sensor that's creating a temperature alarm as the rack runs low on refrigerant. Based on that, you could actually create a low-cost alarm system that could be incorporated into most stores' energy management systems by using a temperature sensor that's located in the farthest system from the rack, which should be the one that actually be affected by a low refrigerant charge. The system could be programmed with an alarm temperature that's as close to set point as possible without incurring any nuisance alarms, and when this alarm's activated, it could be treated as a refrigerant leak alarm. The system you choose, the monitoring system, needs to be tied to an alarm system that proactively notifies store management of any leaks. A level of redundancy or checks into the alarm procedure should be in place to guarantee that the leaks are not ignored. Unfortunately, direct central leak detection systems are ineffective in highly ventilated areas, such as outside, due to the rapid dilution of the air sample. So they're ineffective for remote condensers or in old type air-cooled compressor rooms. A lot of ventilation. So it's so important to have regular leak inspections where these items can be checked during a preventive maintenance check. Service technicians should check on regular PM on a regular basis to check receiver levels, compare receiver levels to data from the previous visit, and then do a walkthrough with a portable leak detector. In many cases, the first refrigerant leak found may not be the only leak in the system. And the first leak may not be responsible for most of that refrigerant loss. It's important that each technician understands the correlation between the quantity of refrigerant charge lost and the leak rate of the leak found. If the leak found is too small to leak the quantity of refrigerant lost, the technician has to assume there is another leak in the system and continue on with the leak search. And check should be done every 1 to 2 months based on the size of the and type of the system. Large DX systems should be checked more frequently, while secondary systems with mechanical room monitoring may be checked less often. Here, example, receiver level chart is being developed for green chill as part of the best practices guidelines. It's brainchild of a refrigeration mechanic turned supervisor who uses it on his own stores and is finding great success with it. The chart should be posted on every refrigeration system that has a receiver level gauge. And every month during PM check, the receiver tech would then place a dot on the chart indicating the current receiver level. Of course, it has to be taken that the level that the system is in the same mode, where it's not in flooding mode or in gas defrost or heat recovery that could affect the level. And if the level is down from the previous month, it could be an indication that there is a leak on the system. Should be established for both the response time for a refrigerant leak alarm, as well as the time to find and repair the leak once a technician is on site. To a refrigerant alarm should be as short a time as reasonably possible. Normally in most areas, technicians should be able to respond within 2 to 4 hours. And if you have a major leak, large quantities of refrigerant can leak out of a system in a very short period of time. So, response time could save a considerable amount of refrigerant. This can be found and repaired within a 24-hour period. If a major component that is not readily available is leaking and needs to be replaced, that component should be isolated from the system or get temporary repair if possible. But should a component be left to leak without repairing or isolating it. And it should be established to require a store manager to assist or provide assistance to the service technician in unloading any product from a display case that is suspected of leaking, so that a thorough leak check and repair can be performed without a delay. Once the repair is made, the repair should be verified immediately that it's leak-free. If the system was documented to be over a 35% annualized leak rate, the leak should be checked again within 30 days to verify it's leak-free. And it probably would be a good idea to do that even on smaller leaks. The verification should include a check of the repair area as well as the receiver level to ensure that no additional refrigerant was lost. And drop in receiver level is an indication that there are more leaks in the system. System may require more refrigerant in the winter to permit flooding of the condenser to maintain a minimum operating head pressure. It's known in the industry as a winter charge. This charge should be kept as small as possible using split condenser valves, fan cycling, and floating head pressure control. The total annual charge may only need to be used for a relatively few hours of the year, and the rest of the time it's stored in the system's receiver, and this results in a system that has an excess charge 90% of the time. If a leak occurs during this 90% period, there's a potential of losing the entire winter charge before the refrigerant loss will begin to affect case temperatures. And to minimize this, it's important to document the receiver levels using that green chill receiver level chart. These levels should be posted on the refrigerator rack or in some other convenient locations readily available to any service tech. Some components should be replaced with parts that are more leak resistant or have fewer number of potential leak sources, such as like a discharge piloted EPR valve could be replaced with a suction stepper valve, which eliminates the high control line, provides better temperature control, and is more reliable. Suction and liquid manifolds during a remodel could be replaced with loop piping systems or remote manifolds to reduce the number of fittings subject to rack vibration. And of course, a major remodel where you're considering replacing a centralized system, consider replacing that with an advanced refrigeration system such as a distributed system, secondary loop system, or a CO2 system to further reduce your leak potential. That concludes my presentation for today, and I'd like to turn it back over to Keely. Thank you.
Thanks very much, Cliff. Lots of great information, and I certainly hope that made people enthusiastic and is making them look forward to our leak prevention and repair guidelines that we hope to be able to issue soon. I'm now going to hand over to Jim Gallahan from Giant Eagle. So go ahead, Jim.
Thanks, Lee. Hello, everybody. Eagle is a regionally based operator in western Pennsylvania, Ohio, West Virginia, and Maryland. We have 171 corporate stores, 158 convenience stores, and our stores generally range in size from 26,000 square feet to 126,000, which gives you an average of about 69. Currently, our store footprint is somewhere around the 90,000 square foot mark. Utilize, for the most part, a lot of different components and a lot of different system designs, but for the most part, it's rack systems. With 171 corporate stores, we don't standard prototype. That seems to change every couple of years. We tend to replace or build new stores, 5 or 6 new stores a year. Our changes, much of our growth comes from acquisition stores. We've 5 acquisitions in the last several months. The maintenance position stores typically will see usually a lesser preferred than we'd like to see, and when we first take them over, then as we make our changes, as we do our things, that we see rates improve. Currently, 3 secondary stores in operation with a 4th one under construction. Central compressor rooms, usually at the rear of the store. Our refrigerant lines are in stores 10 years old or older, are typically run underneath the floor in pits. Stores newer are now ran overhead. Almost stores have 2 to 4 parallel compressor racks. Some of our stores are currently over 25 years of age, and we are slowly replacing them as we remodel and expand. We use hot water and heat reclaim in most of the stores, and our standard defrost design is gas, even though we do have a few electric defrost stores in place. In 2007, we switched from a time and material contract scenario to a comprehensive service and maintenance contract. And that involves 8 different contractors in our portfolio. Part of the contract, service providers are responsible for providing the refrigerant in most instances. There's accountability on their end to be diligent in finding the leaks that are in the system. When we went to this format, surprisingly, for the first couple of months, the contractor was in place. Didn't see the performance we thought we would, but as we partnered with these guys, as we learned ourselves, and as they learned, we've seen the leak rates start to turn around, and right now we're experiencing some of our lowest leak rates with the maintenance contract in place. Reducing the losses in a major leak is response time, as Cliff said, and that's huge in getting the leaks fixed in a timely manner. Our contract calls for a 2-hour response time with a 6 to 8 hour restore threshold. The contract service we have in place, the maintenance contract we have in place, has documented specific tasks that are performed by the contractors, 17 in total, and one of those is what you see here is the monthly refrigerant leak checks. They're required monthly to check the display cases, walk-ins, root sensors, compressor rooms, pits, all typical areas you would see that have leaks. Our reaper levels are required to be recorded for every PM visit, then also record them for every service visit that they're in the store. Potential leaks are repaired when found. We don't allow them to become follow-up work or work to be performed during slow work periods. And that Cliff also mentioned was the compressor room storage. We don't allow any compressor room storage. When it does, and we've had instances where the equipment that gets in there does cause leaks. The central infrared leak detector installed in every store in the chain except the most recent acquisitions. The detector is connected to a web-based refrigerant tracking system and back to our refrigerant monitoring service, which continually checks the status of the detectors in all of our stores. The monitoring service sends an email notification to myself and to the refrigeration contractor involved And for alarming critical level leaks, the service provider is dispatched via our call center. The state's refrigerant reporting program is also part of the EPA reporting requirements. And as good as any leak detection system is, it's able to monitor every area of the store, so we still have to rely on good preventative maintenance programs. There's the monthly leak checking status of display cases, outside units, as well as monitoring of the receiver levels. We've been developing a dashboard that encompasses more than the leaks. It encompasses our refrigerant leaks, our rack energy, and service call and maintenance volume that is issued through our work order system. Everybody knows these tools are only as good as the technicians have trained how to use them. We get ongoing training with the technicians, also with folks in the Giant Eagle that utilize this system to help us manage and track what's going on. If any of our leak rates at any service organization exceed our target goals, we provide retraining or work with them, partner with them to see what may be the issue so that we can continue on to drive the leak rate down. The leak testing system we use is very low. It has low maintenance costs other than replacing components that age. The consistent sensitivity is by a yearly calibration. That's part of our maintenance task. They have to yearly calibrate that. There's a kit available for that. Each channel can be refrigerant specific so that we can monitor any different areas of the stores. Our level alarms are based on what we need, and currently our level is at 50 parts per million. We haven't noticed any false alarms. While you get them every now and then, it's based on some stuff that they use in the store, but we've pretty much eliminated that now based on where we put the sample points. Our sample points are between 8 and 16 points in every store, depending on the size of the store, and the system notifies us when a monitor goes offline. And we'll view things from remote locations, so it makes it a lot easier where you're not sending people on trips out there to find may not be wrong. What you see a typical layout in our stores, the refrigerant monitor, the S system, which is typically a CPC or Danfoss system, are routed through a local information center. This secure access that our IT department likes because it doesn't up on our network and it frees up some bandwidth. The system all total, it also allows us to add the rack energy, refrigerant leak, call volume, and almost any other IP addressable equipment that we'd like to monitor to be shown on the dashboard, and I'll show you some stuff later. This is the dashboard I was speaking of. It's the energy refrigeration and maintenance dashboard. Includes refrigerant management, LIFO, rack energy, based on rack-mounted CTs that data is collected, and then it has the maintenance work order for preventive maintenance and service calls. The dashboard in here is available to all of our service providers. They see this when they first log in, but they are only able to see their contracted sites. They don't have visibility into anybody else's sites. Our refrigerant management system leak detection is all based on data collection, and annual leak checking, and the utilization of that data for repair versus replace. We basically have a traffic light system so that we know that green, yellow, and red indicate where we're getting into problem areas, and the contractors have found that very easy, very focused on what they need to do so they don't waste time in areas that they don't really need to be looking, even though it gives them some insight for their overall picture. This is out of what you see, the email alerts, the stepwise refrigerant leak calibration contractor, along with the graph that shows the leaks that are happening in the store. Our water threshold is at 50, so most of those are smaller leaks, but it's an indication that there was obviously a larger problem coming. The system, a defined set of criteria met, and an alert, like you see there on the referred status, comes to myself, and we start looking at what's causing the issues, if it's the aged equipment, and that gives us some research items that way that we can go back on. The technician shows up at the store after he records or after he has an event, and he goes in there and puts refrigerant in there. He goes into the system, or can go into the system and use this tracking record. He answers a few questions. The leak location, the cause and action are all on the screen. We tried to make it simple, so we limited the choices to 6 to 12 choices for each category, and we eliminated the choice called other, and we eliminated that because we didn't want it to become a dumping ground, so we didn't know what was happening, so we could target where we needed to go. The system allows us to track usage by month, also by every 6 months, and in a 12-month rolling average. The columns can be sorted in numerous different ways so that you could research and develop you need to do to fix and repair all your other systems. This is another screen. This is store leak ranking. We can sort this by the store from bad to worst, or the best stores in the chain, and compare how old they are, the types of equipment, and again, it's all in the vein of reducing leaks, reducing costs, and hopefully replacing equipment that's aging or is no longer viable. This brings us an opportunity to compare ourselves, each store, to this year versus last year. We could also do it by contractor, but typically it's store against store, and it allows us to view trends and where we're going, if we're getting better, if we're getting worse, and again, it's all data to drive improvement. This is this example of a monitoring point. A typical store, we have monitoring points, rack B, rack C. All the points are a one hose point that goes over to rack B, and then as that hose gets over there, it splits off with 4 individual, what they call a spur kit, and gives you complete coverage of a rack. It also happens on the cases the same way, and gives you just a more better footprint of coverage in your areas. This is an example of some of the information that's available on the website once it's all collected and we go through it. Left side of the chart lists the refrigerant usage sorted by location. The right side is usage sorted by cause of leak. No surprise that 4% of the leaks occur at the racks and in the compressor room. This is why this tube installed in there, and then the spur kits are added to cover all 4 corners of the rack. Second most leak-prone location taken as a group with the suspicious cases. Air sampling tubes located in the kick plate area of case lineups detect the presence of refrigerant from a leaking case, but a technician still needs to pinpoint the leak by using his handheld, going through the case, whether it's opening doors or produce cases, and just targeting the specific location. Eliminate the 2% leak rate of the roof condensers and the 2% of the AC equipment. The majority of the remaining leaks should be picked up by the refrigerant monitor. Nothing's perfect, and it doesn't always happen, but for the most part it should. This part is that most field piping, which includes hundreds of feet of tubing, both in the ground and above ground, only accounts for 8% of the store leaks. All information is used on this slide our high usage stores and our high service providers. For equipment, the display cases tend to be where we replace them when we do line of business type of stuff. The manifold assemblies. The high usage providers, we use KPIs, key performance indicators. This helps us train and learn from what we're doing to improving, and it also helps us lower our costs, and at the same time it helps the contractors lower their costs for their preventive maintenance contracts. What we see on some of these is incomplete checks, slow response times, and that just increases our cost and increases our carbon footprint as well. So the leak balancing syndrome that Cliff mentioned is also a problem, but as we train and go through this, we've reduced that greatly. The inward system allows us to research, replace versus repair, so it helps us develop all the solutions that you see here. Current testing, what Cliff was mentioning in regard to the we temperature alarms on one circuit at the end of the liquid hover as an addition to capture as a capture point for low liquid levels that the leak detector may not capture, or the low liquid level indicator may not alarm at that point. And we've seen some results from this that are promising. This is just a slide of why it's succeeding. The corporate executives have bought into this technology. They fully support what we're doing. They've invested in this technology, and it's working, and they're 100% behind us. The service providers are all trained. Our in-house people are also trained, and as we utilize this, you get recognized for your accomplishments. We measure all of our performance against goals, and as you go through that, it just continues to help drive things to a better place. At the corporate or executive levels, they recognize us as a team, but they also do that for several other categories in the company. But we thought it was important to also recognize our contractors. They're an extremely important part of what we do. They really what helps us drive our leak rate, and so we recognize the contractors as their administrative offices, but also with the slide at the bottom that we recognize each individual technician with the tools, so that hopefully instill some pride in what they're doing out there and realizing that we are paying attention and that we do appreciate what they do. And that's Scott Keeley.
Okay, thanks very much, Jim. That's a really impressive data-driven refrigerant management system. I think it's easy to see that Iron Eagle doesn't have the lowest refrigerant emissions rate in Greensill 2 years in a row by accident. It's a result of a lot of hard work. At this point, I'll turn the presentation over to John Perry, who's going to continue with a completely different aspect of leak prevention and repair. So, John, go ahead.
Okay. Can you hear me?
I can.
Okay. All right. Talking about hydrogen leak detection, and wanted to out and just let you know hydrogen leak detection is very similar to standard electronic leak detection. You're using a tracer gas inside the system for on an installation. The gas using to put hydrogen in the system is a purchased gas that is Hydrostar. It's 95% nitrogen and 5% hydrogen. It's a very gas. The part per million is 1 to 2 parts per million. In concentrations of 5% or less, it's not explosive. It's so nice that it is very green, very safe. It meets the ISO 14001 and 10156. So gas to use there. And when you buy hydrogen as a tracer gas versus what's standard, it uses a current electronic handheld leak detector to do their gas detection. Standard detector will use will pick about a 2 ounce per year leak on a 404 tracer gas with a 5% concentration at 100 pounds. Concentration of 404A on a fully operating system is 100%. About the best it can find is a half an ounce per year, and that's typical handheld electronic detectors. If you look bottom 2 slides down here, what I'm trying to show you is that hydrogen is capable of detecting leaks smaller than your standard pressure decay test with traces. It's almost as good as the helium that can be conducted in a laboratory. Over in the bottom right, you will see that at 10⁻⁷ cubic centimeters per second, you can actually test a leak that wouldn't leak a cubic centimeter per second in about 7,000 years. So very minute detection. The equipment can cost anywhere from $5,000 to $15,000 unit, and that's in comparison to a $300 handheld electronic leak detector. And the other thing you need, of course, is the hydrogen gas, which runs about twice the cost of dry nitrogen. And when you conduct the tests, the is essentially the same. And the thing that I see as a difference is when you have this expensive equipment job sites that you do have a risk of damaging a $15,000 tool, someone dropping it or stealing it. So you figure that in there. It worked very well. Our first test site that we tried this on an entire store, we test store to 300 pounds of pressure with nitrogen and let that hold for 6 hours. We did not see 1 pound of pressure drop on that system. Because I intended to do 300 pounds of pressure with the HydroStar but didn't order it enough, we were only able to get the system to 125 pounds of pressure. But we still go to that entire supermarket, found 8 small leaks, and those leaks were repaired. When we made repairs, the vacuum test was one of the best we've seen. We got down to 125 parts per million, and it held for 24 hours, and this system was about a 200 cubic system, so very large, one rack system for a store. I was using the highest level of detection the detector could use. One of the leaks was kind of deceiving in that when we found the leak, it looked so large we weren't seeing a hydrogen test leak that I didn't believe the people had conducted the test properly. So I had them repressurize the test, and it went back with the standard nitrogen refrigerant and the soap bubble test. We could not find the bubble, but with the nitrogen, it just bubbled up to the point that you couldn't believe a leak was missed. This is not that leak, but a similar leak. This was a suction riser here. And on the left, pressurized to 300 pounds, you'll see HydroStar. And it's bubbling out from where my arrow is and streaming down the pipe like this in a vertical direction. The leak at 3 pounds of pressure with R22 nitrogen is a little area here, and that's as large as it gets, and it remains there, and there does not appear to be hard motion to it at all, and you can see that the size of the bubbles with a more zoomed in picture just much more difficult to locate. Using this system in other areas, we've done tests on oil lineups and things like that, and gone in the day before, and you cannot find a leak in the system before we were going to install the cases. The cases that were remaining in the lineup were day before with standard procedures with electronic leak detectors, and when the cases out. We found leaks in the cases we weren't changing on hydrogen test immediately. Today, anything that we've tested has not had a leak due to the testing, and we've consistently been able to get any of these systems down below 100 microns. Stores that have had problems, we have done 4 stores now. When I say full stores, I'm meaning just a system in the store was tested. But the first we did closed after 7 months. There was no leaks. The second one we have done has been open maybe and a half, and the only leak we have had at that store was we just changed the heat reclaim tank. The actual work they just did was a small leak. No gas was added, but it was a miscommunication. The third store that we have done, there have been 2 leaks. Neither one of them were termed to where the hydrogen couldn't find it. One of them was a service problem where somebody adjusted a superheat, did service cap back on the TXV. The second one was, I forgot the term, but this ice formed in a pocket in a solder and busted the line as it swelled. So it was a tight joint at the time of installation. That ice expanded, contracted, it eventually burst the pipe, but unrelated, in my opinion, and the manufacturer's opinion, to the initial test. The 4 had a leak tie-in joint, so we tested the system, and solder joints we tied it into. There was a leak there, and then there was one section was untested that had a leak, but everything else, very, very tight systems. There's been about 2 years worth of installations for us. Having that work and trying to improve the system, went and took a closed door, did testing on a laboratory type system where an old system in the old building, we set to do repairs, testing, to make a super tight system and learn things about vacuums and dispel some myths. And I always had heard is you could oversize a pump, and the other one was that you can't pull a good vacuum with oil present. The testing done for about 10 weeks, multiple tests, the hydrogen allowed us to find leaks. We were able to control that test system down below 10 microns. Different rich micron gauges, we were able to get to readings of 0. For 4 and 5 minutes, the micron gauge would remain below 0. At 0 for 4 to 5 minutes, and we could hold 20 microns for a period of up to a week on a 15-year-old system with oil in it, and we actually heated oil and burn it in the system to prove that we could still get the deep microns with oil in the system, the way we're pulling vacuums. Brought us around to a rush to pull vacuums. We call it dynamic flow. We've made them fold for pulling with the system. Start out with an installation. We bring this vacuum pump with this dynamic flow manifold. We test the pump, the oil, micron gauges, and the manifold at the start of before it into the system. Then we start in, pressurize the system and the manifold. We then use the HydroStar hydrogen leak testing equipment to test for leaks on the entire system. We pressure test and a dynamic flow. We pull vacuum all on the suction side and to introduce the HydroStar in the liquid line while we're breaking our vacuums. And repeat this purge, if you want to call it, until a vacuum is achieved. So breaking down just a little bit, we all try to start with a great pump. We make sure the pump can achieve a vacuum of 50 microns or better at the beginning of the test. If you can't get the pump to 50 microns, you need to get a different pump, in my opinion. Here's the setup of the rig, and in that you have a liquid side and you have a suction side. Able to manipulate these circles, they're ball valves, to the dry gas that HydroStar move through the system in one direction back towards the pump. We measure microns at the farthest point of the system and right next to the pump to monitor the vacuum. And after we tested this, we then solder it into the system. We make sure we remove this radiator core right next to the pump so that you cannot pressurize the pump. And then we shut the ball valves to the micron gauge so you can't damage your micron gauges. The is then filled with 300 pounds of pressure for our systems, but whatever your max pressure is. On your pressure test, going over everything with this hydrogen tester. There's a kind of schematically the hydrogen connected to the system, and the arrows follow the way the gas flows throughout a standard circuit. It would be similar for an entire rack. We've got the ball valve closed on keep pump separate from the liquid side here, and have the ball just above the pump shut. We're charging aside from the liquid line. We're keeping pump valved off. We're keeping on gauges valved off, and just holds while we leak check. When the test is done, we always do it for a minimum of an hour. Micron gauges should read low microns because you've them off when you've done your initial test. We generally start the pressure test, let it hold 50 to 100 pounds for a little bit to make sure it holds tight, then go to max pressure. We HydroStar connected the entire pressure test and the flow portion of the vacuum test. We'll hold the pressure for a minimum of an hour, and held for an hour and tested everything. We'll crack the ball valve next to the pump, relieve the pressure, radiator core that's open. We bring the system down to atmosphere. We close the core and cap the radiator valve. We reduce the HydroStar regulator pressure to 2 pounds, or less 0 to 2 pounds. The system is sitting at atmosphere and ready to pull a vacuum. At that point, we'll keep the ball valve on the liquid side of the pump closed and open the ball valve to the pump, turn the pump on, and start pulling our vacuum. HydroStar can flow from the far liquid all the way through the system. And your transducers to your micron gauges. And let's see, I'm getting a little lost in my slides here. Keep on the. You just want a vacuum at this point. Should pull down rapidly near the pump to 1,000 microns, and the one to the hydrogen should be something around 5,000 microns. If it's higher than that, that's okay. The point is the one closest to the pump should be around 1,000. You can crack the HydroStar bottle, and what you're wanting to see is the gauge on the liquid side into 80,000 microns, so you know you've got some flow through there, and you'll see that the vacuum out of the pump will rise to about 5,000 microns. Let it run about 60 seconds, and you'll see it come back down to 1,000 microns or so. We're typically doing that about 5 times. If you want to try a little more, that's fine. But point is that your gas through it, it's a very dry gas. It's imparting energy into the system. That energy releases the moisture off the sidewalls of the pipe and flushes it towards the vacuum pump. Not breaking vacuum all the atmospheric pressure, which would put a tremendous amount of molecules in there and waste your time pulling it back down to a low micron. So this greatly speeds up a vacuum. You've purged what you're comfortable, I would say 5 or more times. You're going to disconnect the HydroStar from the system with the HydroStar flowing so that you engulf that Schrader with dry gas as you put the cap on it. Once it's capped, you're going to pull. This is going to pull down as we can. We've constantly below 50 microns. Cycling the solenoids and turning all the valves if possible while you're in a deep vacuum. That can speed up things a little bit. And if you are comfortable the system is going to pull down, you can open the vacuum manifold to both sides once you've seen some very low readings, as long as you realize when you do micron gauges are reading very close to the pump, you have to shut the system off and allow it to settle out standard micron reading on the system. I know that was quick. I'm going to hand this back to Keely and hopefully answer some questions.
Great. Thanks so much, John. Just a reminder, everyone's charts, including John's, with step-by-step vacuum procedure, will be up on our website on the events and webinars page. So I know that was a very detailed step-by-step process. You'll be able to pull that right off of the Green Chill website as soon as we get it up there. So I want to open things up here to question and answer. As I said before, if you have a question, feel free to click that button that looks like a little hand down at the lower right-hand corner screen, which alerts me to the fact that you want to ask a question. And then if your phone is muted, for those of you who joined us a little bit later, we tried something different this time where I muted everybody's phone from centrally here to try to cut out a lot of the background noise that we often have. So if you do want to answer a question and ask a question and your phone is muted, you're going to have to unmute your phone by pressing *6. So does anybody have a question? Who wants to start us off? Questions? I can't believe that everything is perfectly clear regarding leak prevent and repair, because if it were, everybody would have a 0% leak rate. Ray Saraceno, do you have a question? You might have to press *6 to unmute your phone because I'm not hearing anything. Yeah, now I can hear you. Go ahead.
Okay, great. It's the engineer in me that has to ask this question. I'm not familiar with store refrigeration systems to the level of detail that we just went through, but I assume that the vacuum is critically important to get all and therefore all moisture out of the line, and then you're going to have and you're not going to have that freeze-thaw cycle that's going to lead to burst pipes. Is that correct?
Do you want to take that question?
Sure. It's definitely up and having the system, although the levels of microns that we're going to are not critical for that purpose. The point of farms trying to get vacuums to that level of deep vacuum is to prove that everything is tight for refrigerant, really. I only was concerned about moisture and icing up in the valves and things like that. I would be more than satisfied with the standards that have been out for 40 or 50 years of 500 microns.
Okay, thank you.
Corky? Might have to press *6 to unmute your phone. I'm not hearing anything.
Hello?
Yeah, go.
Hey, Keely. I was just wondering if that receiver level chart that Cliff had talked about was available on the Green Chill website.
We can certainly Actually, yeah, it's a good idea. We can certainly make that available right away. That's a nice tool. You don't have to wait for the leak prevention and repair guidelines to come out. It is in the leak prevention and repair guidelines. We're going through the second draft of the guidelines at the moment, and that's actually going to be ready shortly for peer review. But it's a good. We can make that that tool available right away on the website. There's no reason to wait for that, so we'll get that up there. And definitely, I'll send a link out to all of our Green Shield partners, and I'll put the link to that on our Green LinkedIn group for everybody else.
Thank you.
Thanks for the good suggestion. Does anybody else have any questions? Ray, did you have another question?
Oh, sorry, no, I didn't take my hand down.
Oh, it's all right. Okay. Joe Westerson, did you have a question? You might have to *6, Joe. I'm not hearing anything.
Oh, can you hear me there?
I can. Yes. There you go.
Oh, okay, great. I had a question about the receiver level as a way of tracking leak. I know from reviewing some records that it sounds like there's seasonal adjustments and other things that can affect the level in the receiver, at least according to the people I talked to. Is that the case, or how good is that receiver level graph at telling you whether you have a leak or not?
I'll ask. Well, start off. I'll ask Cliff if he can answer that question, and then Jim and John probably have something to add to that. Cliff, do you want to start us off?
Sure. An issue where the problem with that receiver graph is that you have to have the system or basically the same condition every time you level. In other words, it should not be in flooded mode where the refrigerant is logged up in the condenser. It should not be in gas defrost. The heat recovery should not be off. And even with that, there's probably some fluctuation in it. But the trick is to get the system at the condition every time that you measure it. And that's probably easier said than done.
Okay. Is something special to bring to that same condition, or is it you kind of wait, or how does that work?
You probably have to do it. If it's a cold winter day, it's probably not the best time to measure it. You maybe have to wait for a warm day, or be able to lower the pressure temporarily to get the receiver, get refrigerant back out of the condenser into the receiver. Like I said, it's a little easier said than done. But it's a tool, and it is a good tracking tool to be able to check from 1 month to the next what your receiver levels are. We're not perfect, but it's better than doing nothing.
Mm-hmm.
Jim or John, do you have anything to add to that?
I'll add that the receiver is a good way to track larger leaks in the system. The level indicators out there where you can do this with computers, all some expense to that, but this is a more in a way on older systems and systems that aren't equipped with that to go around and keep track of it. Technicians always check receiver levels as they go throughout the stores, but checking them out is probably something you're going to want to push with them if you don't have an automated way of doing that.
Keely, it's more of a, you're looking for trends in your levels. As you go through there, the winter time you may see a certain level, but then as you see that, if that starts fluctuating down, you may have, you'll have the potential of an issue in your system somewhere.
So just to follow up on that, is it? I've heard from some people that as I've said, this is certainly a lot better than doing nothing and just not seeing any trend of leaks until the ice cream starts melting or something like that. But is it true that this will that by the time you see a leak by your receiver level, that already quite a bit of refrigerant has leaked out? I've heard that as a bit of a criticism of completely relying on this method. Is that true?
Probably is. You would lose less refrigerant by tracking the receiver than if you would let the receiver go to empty and just rely on the refrigeration temperatures to start elevating to actually cause you to react to a leak event. So it's trying to capture or save the residual refrigerant that's being stored in that receiver, before you use all of it. Granted, you could lose, before you can reach where you feel that you have a leak due to the drop in the receiver level. You could lose 10% or more of that receiver level, which could equate to 50, 80, 100 pounds of refrigerant.
Okay.
It's not perfect, but it's better than losing 300 or 400 pounds of refrigerant.
Okay, but you certainly find leaks, or let me put it this way: leaks that would show up on a receiver level chart like this, would they show up more quickly with an automatic leak detection system?
If you have a direct system that's measuring refrigerant parts per million, and the sensor is located somewhere near the leak, which could pick up the leak, it would be great. But if it's, let's say, a leak on the roof, it wouldn't be able to pick that up at all.
Okay, great. That's a good point. Okay, John, I saw that John Berry, that you have your hand up. Did you have a question?
I do. I was going to ask Jim on his chart where he was showing percent of leaks, categories of location and by cause, if that was percent of events or if it was poundage.
Number of events. I'm pretty sure I'm trying to find that slide now. It's a section of all the data, but there is some refrigerant charges in with that. But it's more the percent where the leaks are.
Okay, I appreciate that.
I'm trying to find the right chart too, and
It's
not
near the end,
finding it.
Keely. It's 4 from the end or so, but
called using the information.
Yeah, using the information is percent of where the leaks actually are in the system.
Okay, there we go. All right. So you said that's by number of events?
Yeah, and where they fall, how many times, as an overall picture of the equipment.
Okay. And John, the basis for your question was that if you did these percentages maybe by amount of refrigerant leaked, might have different percentages? Okay.
Yeah.
That's a point. It'd be interesting to see percentages like that by pound of refrigerant. Okay, good. Well, thanks for the question. I have CTA. I guess I know the CTA guys. You might be sitting there with a couple of you around the conference room. Does someone answer a question? Ask a question?
Hey, Caleb Nelson, can you hear me?
Yes.
I guess typically, talking about leak detection systems, we typically use a leak detection sniffer system that has the multiple zones, and we would run the sniffer tubing out to the different boxes. Again, my understanding is those will sniff a box, they'll clear it out, and then sniff another box, clear it out, and then just go around. So it might be a half hour between each box that it's sniffing. And I guess we've got a store that's only got like 2 boxes, and I was wondering if, I think CPC makes a sniffer that you could mount on a box, and it would just be dedicated to that box, and it would basically be sniffing it 100% of the time. It would have a quicker or a more alert, more reliable alert for that leak. I guess I don't know much about that system. Does anybody have any information on a different type that wouldn't just use sniffer tubing all to one central location? That would be a more effective solution for a store that only had a couple boxes.
John,
put that up to anybody that might have some experience with that type of system.
I know the CPC makes a unit. I actually believe it's manufactured for them by SA, but it's more solid state system. It doesn't exactly the components, inner workings, or whatever it works on sound, or if it does have some kind of infrared pad in it or whatever. But yeah, they do make a device like that. It's a solid state-based device, and you just run cable to it.
On that, Perry, they have both types. They have the wall-mounted that is an electronic wired system that is what they call an RLDS. It stands for infrared leak detector or something like that. And then they also have the system similar to Parasens that have tubing that have filters and pull it back. And if you're doing Z2Z, you may be able to talk to them and get a better than a system that has 14 or 16 channels, paying for all the channels. Pleased with the RLDS we've used. We've only used them really in motor rooms, but they're superior to what they were putting out a few years ago with the elements that used to burn themselves up over time. I don't mean like on fire, but just utilizing their elements. Cliff and Jim have used a different manufacturer and have been very pleased with a larger mill system. So maybe they could talk on how that works.
MRLDS, those alone, do you know what they have for an output as far as, because even if we have 2 or 3 boxes, we'd still probably send a signal, just a low bit signal to the Danfoss or CPC or whatever, just to hit the internet that we've got a leak.
5, I think.
Okay.
But yeah, I can integrate with Danfoss.
Anybody add anything to that? It's a good one, or good questions. That's the purpose of these webinars, to have everybody share information. Hopefully that leads to individual stores with lower emissions rates. See, anybody else? If nobody wants to add anything else to that, out to Ray Saracino has another question.
Thanks. I thought the presentation from Giant Eagle was impressive for the comprehensive leak detection system they have, but they have something on the order of 170 I forget the exact number. I'm thinking of smaller chains, and are there highlights of leak prevention and detection that are lower cost and don't require as much upfront capital for the centralized system type approach, and they might be more suitable to smaller chains? I'd love to hear any comments on that. And then also I wonder if in the prevention and detection guide that's being put together by Green Chill, if there'll be some or focus on methodologies that are appropriate to smaller chains.
Let's answer the second part of that. We currently our approach to leak prevention and repair, as Cliff said at the beginning, we recognize there is no, one cookie cutter approach that will work for every store. So the goal of our leak prevention and repair guidelines is to present a host of best practices that people can pick and choose from. I would certainly hope that smaller stores or smaller companies with fewer stores would feel that many, if not most, of the options that we're going to have in those guidelines are just as applicable to them as large companies. So it's certainly a goal to have our guidelines be useful to stores and companies of all sizes. So when we send it out for peer review, it's a very good question for us to the peer review questions. We'll make sure that we address that with our peer reviewers and get their feelings on whether they feel that the guidelines are applicable to smaller stores or smaller chains. So I appreciate that question, and I've noted it down here that we address that in the peer review process. But in terms of the first part of your question, which parts of Giant Eagle's presentation, and I would open it up to John too. Smaller stores, might not be able to invest in hydrogen leak detection systems, but there might be parts of John's suggested process that he presented that should be done in every store, whether you have hydrogen leak detection or not. And I'll ask two to chime in on that question. What about small stores and smaller companies?
Okay, I can start off on that. I think the systems that were presented today are scalable to smaller stores. It's a matter of being able to afford the systems. Some of the systems, like the ones by Giant Eagle, are a little costly. At the same token, you could still use infrared leak detection in the compressor rooms. Most of the refrigerant loss in the racks on most conventional stores. And if you focus on infrared leak detection, maybe in the compressor rooms to start off with, you could probably get the bulk of the losses right there, and then maybe even use the other approaches like receiver level monitoring, or even use the idea of using temperature sensor at your farthest point to trigger a leak alarm. That'd be a low-cost way of putting a system into a store.
Could I ask? The one suggestion in terms of just doing a monthly walkthrough with a handheld leak sniffer. How much does a handheld leak sniffer cost, approximately?
I taught that in my presentation. A standard technician's going to have a leak detector that probably doesn't cost $300.
So less than $300?
Yeah.
Okay. And I know from Green Chill Partners, I've had Green Chill Partners tell me that, the first step in getting their corporate leak rate down was, change in attitude. Making it a priority was the single biggest factor, in their emissions rate down across their corporations. And then I've heard from partners that, just walking through, that they'd be amazed what you find in a store just walking through it with a handheld leak sniffer. That part of this process is critical, and certainly, no matter what size the store or the company, I think that's something that everybody can do on a monthly basis at least. Or John, do you have anything else to add about parts of this presentation that might be particularly relevant for smaller stores and smaller companies?
Yeah, the leak detection system we use is interchangeable. You can use it as we are and continue to develop on it, or you can scale it down to your needs. The the leak detector itself is add on to it in channels of 4, 8, 12, or 16 channels, but other companies out there that make the same, use the same, almost same technology to detect leaks, and the one that John uses, you can place that also in specific areas, and you run your cables. You don't have to rely on tubing or anything like that. But yeah, there's several options available that scale the cost back.
Okay. We've reached 4:30, which was the planned end of the webinar. So if those of you who have to sign off at 4:30, that's understandable. Before I call the webinar to an end, though, I just want to check if anybody. I think this Q&A session is really great. If anybody has another question, we can maybe take one more. Joe Westerson, did you have another one?
Yeah, more. So I heard someone suggest the idea for a low-cost leak detection system of putting a temperature sensor at the furthest point from the just wondering, would that only work once the receiver had gone down to 0, or would that catch things earlier than that?
No, unfortunately, it would have to wait for the receiver to go down to 0.
That alarm threshold would be set on when you start flashing gas in your farthest one on the liquid header, and yeah, you'd be a pretty low level, depending on where your level indicator alarm thresholds are. If you use it, not we're testing that because we realize that even though the indicators don't always catch it if they stick or if they go offline, that we do realize we're getting temperature calls, and that's we're having that gas.
Calendar, you want to ask a question quick?
Yes. Can you hear me?
Yes, I can. Thanks.
Okay, good. I have a question for John from HydroStar. Is there,
sure.
John?
Yes.
Okay. Hi. On the HydroStar hydrogen system that you're using for your vacuum and pulling the vacuum and drying the system out, it's only for new systems, new installs. Is that what you're using this system on?
Yeah, but not just new systems. I mean, if we're having a trouble in a store, we will go, stop, pinch off a circuit, pressurize it, and leak check with that.
Okay.
If we're really having trouble finding something, yes, we will.
Yeah. And the 500 microns, you like to lower than that?
Yes, I like to see the lowest micron reading I can get.
Okay. But is it just your personal preference, or is that something that you're trying to get the industry to move to? Because typically the industry is going to 500 microns, right?
Well, the industry has been at 500 as far as I know back when I wrote any manuals on
forever.
Right.
Yeah.
I've, as part of Green Chill, have put the industry to move to 300. I think 300 is a better number than 500. Does every system need to get lower than that?
Not necessarily.
Tip the eyes of the system.
Okay, now on the going lower than 300, have you seen any issues with oil boiling off in compressors or in a pipe? Okay, because that's typically why the industry wanted to stop at 500, was to prevent that from happening, because you could your oil off if you go below 300 in some oils.
In RSES, there's an article out this month talking from John Tomzik about the pressure of oil. Some oils as low as 100 and some at 10, and I have not seen that and wanted to follow the question.
Good. I'm saying that because I've always wondered that. So I just wanted to touch base with you on that, okay?
Sure.
The receiver, Keeley, the receiver level indication.
Yeah.
You're monitoring your leaks. I think a lot of that would have to do on your receiver level it is conducive to ambient condition and load condition, as where your receiver level would be. So that might be some other point on the graph that you might want to check, so you could compare the three different levels, temperatures and the liquid level might help.
Okay. All right. Take that under advisement. Regarding the vacuum down to 500 microns, I mean, in general, Green Chill has a set of best practices for leak tightness at installation, and we're recommending a three-phase vacuum process where you pull down to at least 1,000 microns, and then you pull down to 500 microns, and final vacuum is supposed to be pulled down to a minimum of 300 microns, and that has to stand for a minimum of 24 hours with a maximum drift of 100 microns. So
back method. Yeah.
Yeah. So and that is available on our website, and as I said, this is going to be available too. John has definitely been at the forefront of just rigorous testing related to pulling vacuums, and I hope you don't mind offering this, John, but if anyone wants to talk to him about this further, it's he's all of the experimenting that he's done with this. He has some fascinating stories.
Anyone who wants to call, as I have time, I'd love to talk with you and hopefully learn something from whoever's asking questions too.
Yeah. If there aren't any more questions, I think we'll call it a day. Thanks so much to our presenters, to our speakers, Jim and John and Cliff. I certainly learned an awful lot, and I would bet that the other attendees learned a lot too. So thanks for your time. We appreciate it. As I said before, the webinar will be available online, and thank you very much to all of the attendees. We appreciate you attending, and we appreciate all your questions. So look for the notice about our upcoming webinars, and we'd like to see you at those too. So thank you very much, everybody. Have a good rest of the day.
Thank you.
Thanks, Keely.
Bye, Keely.
Thank you.
Bye-bye.